Introduction to ArcPy Geoprocessing. ArcPy allows you to automate geoprocessing tasks in ArcGIS. ArcPy provides direct access to geoprocessing tools through modules like ArcPy.management, ArcPy.analyze, and ArcPy.sa. Each tool accepts parameters as arguments and saves outputs to specified paths or in-memory workspaces. Basic example, creating a buffer. Step 1, set up the workspace. First, configure your workspace and environment settings. Import ArcPy. ArcPy.inf .workspace equal d Udemy ArcPy data. Then ArcPy dot inf environment dot override output equal true. Step 2, execute the buffer tool. Use ArcPy.analysis.buffer to create buffers around features. To create buffer, we use this script. Define input, output, and buffer distance. Input features equal cities.shp. Output buffers cities buffers.shp for example, and buffer distance 100 meters. You can change this number according to your purpose. Then running buffer tool. The function is arcpy.analyze.buffer in capital B. Input feature cities. Output feature cities buffered.shp. Distance 100 meters. Dissolve option all. Solve all into one feature. Line side full. Line it type round and method planner. Then print buffer created, comma output buffer. We copy the script, paste it in Python window. In the output, buffer created, name it cities underscore buffers.shp. Step 3, add the results to ArcMap. To load the output into ArcMap, we use mxd equal arcpy.mapping.map document current df data frame equal arcpy.mapping.list data frame mxd o first layer. Then arcpy.mapping.added layer. Use df data frame comma arcpy.mapping.layer output buffer. Cities with buffer added to layers. Expand applications. Application 1, clipping layers, clipping rasters. ArcPy.check output extension, spatial, input raster, for example, converted.tif, and clip mask. The shape file is rania.utm38.shp. Clipped raster equal, we name it clipped Landsat v4 new 1, for example, tif. Then extract arcpy.sa.extract by mask. Use input raster and clip mask rania.utm38. Save clipped raster, clipped Landsat v4 new 1. Let's copy the script, Control C, and paste it inside Python window. Control V, double click. The process is done. Application 2, extracting vertices from geometries. We use rivers.shp, for example, as input layer, and output vertex. We name it river vertex.new 1 shp, for example. The function ArcPy.management.feature vertex to pointers. Use input layer, rivers, output, new name, point location, all. Let's copy the script. Control C. Paste it inside Python window. Control V. Double enter. The process is succeed. We have output feature class river vertex new 1.shp. This is the created vertex from rivers. Application 3, reprojecting layers. Let's reproject shapefiles. For example, Rania 4326.shp. We change its shapefile to UTM38. So we name the output layer Rania UTM38 new 1 shp. Target CRS equal ArcPy.spatial reference 3238, which is represent UTM zone 38 north. ArcPy.management.project in dataset, use Rania shapefile, output dataset, we give it new name, then output coordinate system, the target which we needed is 3238. Let's encode this, the first step, the comment, copy script and paste it. The shapefile is reprojected. The output dataset of feature class is Rania UTM38 new 1.shp. Advanced tips. Tip 1, using in-memory workspace. For create buffer in memory, we use memory buffer equal in-memory buffer temp. The function arcpy.analyze.buffer with the capital B. Use royadis.shp and memory buffer, for example, 50 meters buffer. Use in-memory layer in another tool, arcpy.analyze.clip, memory buffer, boundary.shp. So clip the roids based on the boundary shapefile. Name it, clip it, buffer 1, for example. Let's copy the script. Paste it inside Python window. Double enter. The clip done successfully. Tip 2, batch processing. Look through files in a folder. For example, you can create a buffer or any other processing for a list of shapefiles inside the input folder. So for batch processing, we use import ArcPy, then import OS to dealing with the Windows files, set workspace, and environment settings, ArcPy.env workspace data folder inside my C. Then ArcPy.env override output equal true. Define input and output. Input folder is input in C and output folder inside C. Create output folder if it does not exist. Process shapefiles for SHP in OS list directory from input folder. If each file ends with the .shp, build path, input path equal OS path join, input folder .shp, output path equal OS path join output folder, buffered %s, skip missing files. If not ArcPy exist, input path, print input file not found. Process notification, print processing %symbol as input path, and print output will be saved to output path. Buffer operation, try ArcPy.analyze.buffer, use input path and output path, for example 200 meters buffer distance. Print successfully processed, except error ArcPy.execute error as E. Print error buffering, ArcPy.get messages 2. Let's run the script. Output will be saved to buffered lakes shapefile, successfully processed. Then output will be saved to buffered rivers, successfully processed rivers.shp. We can put a list of shapefiles inside input. Then with this loop, we can create a list of shapefiles which is be saved inside output, buffered rivers and buffered lakes. In conclusion, ArcPy empowers you to automate geoprocessing workflows in ArcMap using Python. By leveraging tools like Buffer, Clip, and Project, you can perform spatial analysis, data conversion, and batch processing efficiently. Incorporate in-memory workspaces to optimize your scripts. With these techniques, you'll unlock the full potential of ArcGIS automation.